Hello, discrete math fans. We're going to talk about a couple of new methods of proof. There's a proof by contradiction and a proof by contraposition. Now, up to this point, we've just done direct proofs. What we do there is we start with the hypothesis of a statement and we make one deduction after another until we reach the conclusion. Indirect proofs are, well, they're more indirect. Now, one type of indirect proof is called argument by contradiction. And it's based on the fact that a statement is either true or it's false, but not both. And this is actually one of our statement forms that we looked at earlier. This is called the law of the excluded middle. There's no middle ground. Things are either true or they're false. Now, what we're going to do is we'll make an assumption that a particular statement that we're trying to prove, we're going to make an assumption that it's not true. Now, if we can show that this assumption leads logically to a contradiction or an impossibility or some kind of absurdity, then whatever assumption we made must be false. And then that leads us to conclude, based on the law of the excluded middle, that the given statement must be true. There's a Latin name for this type of argument. It's called reductio ad absurdum. The idea is that it relies on reducing some given assumption to an impossibility or an absurdity. So the method of argument by contradiction is based on this argument form. Not P implies C, therefore P. Now C is a contradiction here. So if we suppose not P and we lead logically to a contradiction, then we have to conclude that P is true. Now let's outline our method of proof by contradiction. First, we take whatever statement we're working with and we suppose that it's false. That is, we're going to suppose that the negation of the statement is true. The next step is that we show that this supposition leads logically to a contradiction. It leads to something that cannot be true. And then we can make a conclusion that whatever we started with, that statement is true. And we've got some examples to show how all this works. Okay, that's all for now.